So students, today we'll do one activity. We'll measure the density of a solid, and we'll measure the density of a solid that is heavier than the density of the water. The density of the water, you know, that is 1000 kg per meter cube. So why we are taking a solid denser than water? Because we'll take the help of water to measure its volume, because you know that density, to measure density we need two quantity. One is mass, another is volume. Mass and volume. So mass will measure using the spring balance, and volume of the substance will measure the liquid, that is our water. So that's why we need the solid which should be denser than water, because when we put it in the water, it should immerse completely or sink in the water. Then only the water level will rise in the graduated cylinder, and will able to measure the final volume and initial reading, so that we'll get the volume that the water is rising, right? And that volume will, the mass will measure, that volume will rise. So mass divided by volume will get the density of the material. So let us do the activity. So as I told that we have to measure mass and volume. So we have a spring balance, and we'll measure the mass of the substance. This will first measure its mass, then we'll measure its volume using this measuring cylinder. Here you can see on the cylinder the leveling is there. So when we'll dip this object or solid inside this water, the volume will go up, the water level will go up, and we'll note down the difference. That is the volume of this substance that we are putting in. So what we'll do, first we'll measure the mass, then we'll measure the volume, and we'll get the density. So you should hold it properly, and if a stand is available, so better you hang on a stand. Now what you will do, you can see there are marks here over this spring balance. Here gram is written and here Newton is written, that means force, and here mass is there. So you can measure the mass using this spring balance. What you will do, you will just hang this, or if this hook is not available, any substance you can tie it with a massless very thin thread also, you can tie it and you can hang it. So what you will do, now you will just hang it here, and you will note down the initial reading. Suppose the initial reading, due to the extension of the spring inside, there may be little bit, the initial reading may not be coincide with the 0, it may be little bit down due to the due to the spring maybe very old or something, the extension of the spring, it may not be coinciding with the 0. If you look carefully, it is also not coinciding, it is at the first line. So first line means you have to find the least count. So 0 to 10 lines are there, 10 gram, that means one line is 1 gram. So 1 gram is its least count, right? So we'll note down the final reading, we'll find out the difference, subtract it. Initial reading is 1, final reading whatever will come, we'll subtract it. The difference will give us its mass, right? So now, and each line is 1 gram, the least count is 1 gram, you can write in the table. So what you will do, just you will hang it. Now you can see clearly that it is coinciding at 20, just below 20, it is 21 starting from 1, initial reading is 1, and it is coinciding at 21. That means you will note down the reading like this. So here we got the initial mass of our spring balance. This is our spring balance. So here you noted that the spring balance is when we put the object, the spring balance starts from 1, starts from, this is 0, this is 1. So it was initial was 1, not 0, so it has a error, right? So starts from 1, and when I put the mass, the final reading it gave 21. This is 20, so it stopped at 21. That means my initial reading, that is this is initial reading, that is 1, and final reading is 21. So difference is, my mass is 21 minus 1, that is 20, and least count is each division. So this is 20 division, each division is 1 gram. So 20 division into 1 gram, that is your 20 gram. Mass is 20 gram, each division is 1 gram. So it's showing 20 division, final reading is 21, initial is 1, so 20 minus 1, that is 20, and each reading is, each line is 1 gram, least count is 1 gram. So least count, you can write least count is the smallest count, that is your 1 gram for this. So you check your spring balance, what is the least count. Then we'll come to the measurement of volume of our substance. So volume, see, you can now see, you have to see parallelly. Don't see from the top or from the bottom, right? Try to see the line parallel to the your measuring cylinder. Now as I can see, my reading is 35, 36, 38 ml. This is a 50 ml. This is a 50 ml. This is a 50 ml measuring cylinder. So my reading is now at 38. Now I'll dip this object that I measured now inside it, and I will check what is the final level, final reading. The water is rising. So I'll tie it with the thread, then I'll dip it. So tie it with a massless thread. Okay, now it's ready. This is my thread, this is my cylinder. Now I'll dip it and I'll note down the final reading. My initial reading is 38, you can note down. So I'll just dip it and I'll note down the rise in water. Just I dipped. I'll completely dip because also the upper one also I have counted in the mass, so everything is counted. So now I'll dip it completely. Now once it's dipped completely, I can note the final reading. So final reading, as you can see, it's 40. It was initially 38, now it's 40. That means 2 ml and 1 ml. It's a 50 ml your cylinder, and you can see that there are in between 10 and 20, 10 lines are there. That means its least count is 1 ml. So one line means 1 ml. So my water was initially 38, now final reading is 40. So what is the rise in water level? 2 ml. So volume is 2 ml, and 1 ml is 1 cc, means 1 centimeter cube. 1 ml is 1 centimeter cube. Cubic centimeter is 1 ml. So with that I'll convert it and I'll calculate my density of the solid. So let's go to the board again. So already we have noted down the mass. Now with the cylinder, as you have seen, the initial mark was 38 and the final mark was 40. So you will write that initial volume was 38, V1 let's say 38 and final is V2, that is 40 ml. It was a 50 ml cylinder, so this is 38 ml. So your volume difference, the volume of your solid, right, that one is occupied in the water. When it dipped inside, the amount of water that is going up due to the volume occupied by the solid. So means we can write that whatever the volume of the solid is equal to the rise in volume of the in the cylinder. The volume, what is the rise in volume? That is difference 40 final volume minus initial volume 38, that is 2 ml. And as I told you, 1 ml is 1 centimeter cube, so 2 ml is 2 cc or cubic centimeter. 2 centimeter cube. Cc means cubic centimeter. So now we'll find out density. So our density is mass by volume. So mass is 20 gram and volume is 2 cm cube. So you can divide, that is 10 gram per cm cube. And the material we have used here to find out density is I think it's steel. So as the least count is not very means 1 ml, but the density of steel is, the standard value is around 850 or 9 gram, 8.5 or 9 gram per cm cube. That is the standard value of steel. So I hope the object is a steel one, so it will be close to this one. So very close to the value we are getting, that 10 gram per cm cube. Now also you can convert it into kg per meter cube, that we use generally SI unit. So gram is 1 by 1000 and cm cube is 10 to the power 6. So it will go up, 10 to the power minus 6, it will go up. So 1 by 1000 into 10 to the power 6. So it will become kg per meter cube. So basically 10 to the power 3, that means 10,000 kg per meter cube. Or the standard value is 8,500 or 9,000. So we are getting approximate value of the density of that material. And if our least count of the measuring cylinder will be like 1 ml, not 1 ml, 0.1 ml, then we can measure more accurately the density. So like that, any solid you can dip inside this measuring cylinder and you can find, following the similar procedure, you can find the density. Also the mass you can measure accurately. You can use a digital measuring scale, you can take it and you can measure the exact mass, and also the volume you can measure with if the least count will, let's say 0.1 or 0.2, so we can, here it is 1 ml, but if it will be 0.2 ml or 0.1 ml, so more precisely we can measure this density, and accuracy will be almost same. And also I am not sure about the material. I guess it is a steel, also it may vary, not proper steel or something. That's why the density difference little bit. This is the standard value we are getting from internet. So I think this experiment is clear, activity is clear. Any doubt, any concern, just comment in the comment box so that we can discuss. If any confusion, we'll discuss in the next video. Thank you for watching. See you in the next video.